I'd like to end this part by showing a different type of plot. If I double click on the top node here that says Maxwell 3D Design 1, it'll bring me back to the view. So you can always get back and forth to these different views just by double clicking on the thing that you want to see. So in this case, report will bring up that window and lock it in place. And I'll go back to this view. The reason I did this is because I want you to understand with a graphic and a visualization of what's actually being solved. The first thing I'm going to do is I'm going to hide this air box. So if I select the air box, and if you notice up here in the draw tab, I've got these check marks and these X marks. These are different ways of just hiding geometry. It's not deleting anything. It's not removing it from the simulation. It's just getting it away from our view. So it's kind of not in the way is the idea. So if I click this X, it says hide selected objects in the active view, and it just goes away. So the only thing that I see right now is the actual sphere itself. So another thing I can do is if I use this compass here, and if I click on, you can see how the Z is highlighting. By doing that, it's going to orient it so that it's coming directly out of the screen. So this is a nice view for us to look at what I'm about to show you. I'm going to go to coordinate systems, or actually I'm going to go to planes. When I go to planes, I'm going to choose global XY. That's one of the built-in planes. It's just showing me a nice little image of where that plane resides in the view. So that should all make sense. And what I'm going to do now is I'm going to go to something called field overlays. And when I do this, I'm going to choose plot mesh. And when I choose this, I get a name for what the node is going to be. You'll see it's going to get tucked under this field overlays in a second. I also have something called context. So I've got two solution setups. I've got setup 1 and I've got setup 2. So let's go ahead and plot setup 1 first. And when I say done, you'll see this is a two-dimensional representation of these tetrahedral elements that I had talked about. So a tetrahedral is actually 3 dimensions. So it's similar to a pyramid. But in this case, we're looking at a view only in the plane. So it's a really easier way to kind of get a feel for what's happening. But if I zoom in here, I can see this is what we refer to as the mesh. So all of these triangles are basically being solved for the electric field. And you can't see it right now, but it's stored in the results in one of the results folders that's included in our design. So what I wanted to show is that if I zoom in here, and I'll try to get a static view here. I'll get a head-on view. I want to show, let's make this transparent. If I click on the object, I can come in this window here. I could change the color if I wanted to, but I'm going to go ahead and just make it a little bit transparent so we can see the mesh inside. And sometimes that can be very helpful. So I can see what the mesh. Sometimes these shapes can turn out to be very strange, but regardless, this is what took place when it actually did the mesh. What that means is that I now have fields that I can extract and get information from every one of those objects. Let me plot the electric field in this case. So just like before, once I select the plane, now I can go back here and do overlays and plot field, and I'll choose Mag E, and I get some more things here to decide, but I'm just going to leave all the defaults here. I'm okay with all that, and when I do, this is the electric field. And I'm not going to discuss the physics too much of what's happening on the inside, but that's expected that we get zero fields on the inside of a conducting sphere, but we get discrete values, we get non-zero values for things that are taking place outside. If I look at this field plot here, I can zoom out. It gets a lot more interesting when I go to a log plot or a dB scale. So let me try that. Let me just back up so you can see what I did. All I did was double click the scale here. When I do that, it brings up this window. If I don't have any changes to make, I close it. I'm right back to where I was. But I'm going to change it to scale, and I'm going to choose I'll choose a dB scale, or let's try log scale. And what you see here is these numbers are now showing quite a bit of range because we chose to plot in log scale. And we'll talk more about log and linear scales and why they're important, but think of it as a way to compress a really big range of data in a way that we're able to digest. So without using that scale, everything was kind of pegged to the 10 to the 15, whereas now we get to see values that are very, very small. So somewhere in here was the point, the location, at about 100 millimeters, somewhere out here, where our field value was actually analyzed, and it was analyzed by using the result that you see in this color plot and bringing it down to that exact point in space. The last thing I'm going to do is I'll go ahead and turn these off right now. Right click, I can say plot visibility off. I'll turn this plot visibility off as well. Okay, so now I'm going to create 2 more plots before we finish, and this time I'm going to use solution setup 2, the one that was more accurate. But I'm going to give you a different plot. The first thing I want to do is plot the mesh again. So again, choose the plane. I'm going to right click in field overlays, and now I'm going to say plot mesh, and this time I'm going to choose setup 2, and I'm going to just say done. And if you can try to remember what the previous mesh plot looked like, this is significantly more dense. And you can see this has a much more regular structure than what we saw before. And this is a direct result of us choosing higher accuracy settings in the convergence criteria, forcing it to make a more dense mesh, also as a result getting a more accurate solution that we saw. So this is what's happening in the background. The last thing I wanted to do that I'll go ahead and end this topic on is going to be one more field plot, but instead of doing a magnitude, I'm going to do a vector plot this time. And I have to choose the plane. When I go to field overlays, I'll right click, I'll go to fields, and then I'm going to choose E vector instead of E mag, and all this looks good. And now I'm going to have to make a few changes. Well, this is probably good enough. So let me declutter the scene a little bit. I'll turn off the mesh. I'll plot visibility on mesh. So now with plot visibility on mesh 2, and then I'll go ahead and turn the grid off, and we get to see this a little bit better. So this is what we would expect for an electric field. So this is a vector field. So the electric field coming from that point charge, I can see emanates in all directions. Every one of these arrows is attempting to show you what the magnitude is by grabbing this arrow and looking at the color scale, and of course it's also showing you the direction of the electric field as well. So it gives you a really good way to understand what's happening in that physical environment, and it's correlated to the laws of physics and the simple analytical calculation that we had made. And we're going to be spending a lot more time on vector plots, and when we go to subsequent sections where we look at maybe vector addition of multiple point charges or multiple permanent magnets, things like that, you'll be able to see what those vector fields look like, and you'll also get a feel for how they correlate to what you're able to calculate in real time as well. So thanks for watching, and we'll see you at the next session.